What Hess Law basically states is that the energy required to get to a final reaction is going to be path independent. That is, it doesn't matter how you get there, as long as the reactions add up to what we're getting at the end, then the energy changes will be the same. Now let me clarify that by using an example. Let's say we've got a ball on a table and we're going to roll it onto the floor. We know that the ball has a certain amount of potential energy that's going to be dependent on the distance between the table and the floor and acceleration due to gravity and some other things, but we are going to see that this does have a certain potential energy. Now if I put a shelf in between and then roll the ball off the table onto the shelf, then off the shelf onto the floor, what I'm trying to say there is that the potential energy going from the table to floor will still be the same regardless of the fact that there's a shelf in the way. So the fact that the table went via the shelf to the floor is not going to make any difference to the overall change in energy going from the table to the floor. If we apply that to a chemical reaction, this might be an example. We've got A plus B gives C, and we've got a delta H of negative 100 kilojoules per mole. If we break A into some compound D first, it might release minus 50 kilojoules per mole. And then if we react D with the compound B and to give C, then that also might release minus 50 kilojoules per mole. As you can see, the D's will cancel and we'll still end up with this same reaction, A plus B gives C, and still the energy will be minus 100. So the fact that we went a different route to get to this reaction is unimportant, because the energy change is going to be the same regardless of which reaction we chose.